everyone, this is the Theoretical Doctor and welcome back to my channel. If you want to access flashcards on this topic and other videos, do click the link below. I post weekly videos every Tuesdays and Fridays, so do subscribe for more content. Today's topic, I will be entering lipids and it will be focused on triglycerides. So lipids are actually fats and they are organic compounds made up of carbon, hydrogen, and oxygen. Does it sound familiar? Like in the previous videos, I was teaching on carbohydrates, whereby I entered a little bit about monosaccharide, disaccharide, monosaccharide, disaccharide, and oligosaccharides and polysaccharides. So if you have missed out on that topic, do check out the video. Alright, but the difference between fats, lipids, and carbohydrates is that the ratio of oxygen atoms to hydrogen atoms is much lower than carbohydrates. So this is important to take note of. It's important to distinguish the difference between lipids and carbohydrates. Now, some physical properties: they are insoluble in water but soluble in organic solvents. They are less dense than water, have high viscosity, and is greasy. So if you were to combine water and oil, you will note that they actually don't mix. And when you put oil and water together, water sinks to the bottom, oil will float on top, and they're greasy. Chemical properties: they are actually esters formed from fatty acids and alcohol through the esterification process. And here are just some examples for lipids. You have triglycerides, fats and oils, phospholipids, steroids, and also waxes. Okay, so this is how triglyceride is actually being formed. So take note that triglycerides are fats and oils. So they are formed when one molecule of glycerol, okay, so this molecule over here is a glycerol, and three fatty acids. You have 1, 2, and 3. When they combine, okay, through the condensation process, you will actually remove 3 molecules of water. I forgot to add the 3 over here. So you see here, water will be cleaved, water will be cleaved, water will be cleaved. So through condensation reaction, you will form 3 ester bonds. Okay. So now glycerol actually is an alcohol, because you see this part over here, the hydroxyl, they are alcohol with 3 carbon atoms and 3 hydroxyl groups. And fatty acid is a long unbranched hydrocarbon chain with a carboxyl group at one end. So for fatty acid, it's important to know that there are actually 2 types. One is the saturated fatty acid and unsaturated fatty acid. For saturated fatty acid, you have no double bonds in between the carbon atoms. An example would be stearic acid. Whereas for unsaturated, there is presence of 1 or more double bonds between the carbon atoms. And a few examples of that would be linoleic acid and oleic acid. Okay, so I've separated them into 2 tables for you to understand better. This part over here is talking about saturated fatty acids, and this part over here is talking about unsaturated fatty acid. Now, for saturated fatty acid, there is no presence of double bonds. So basically, the chain will look like this, you see? Just C and C, there are no double bonds. Whereas for unsaturated fatty acid, there is presence of double bonds. It'll look like this. Now, because for saturated fatty acid, there is no double bond, there is no kink in the chain. And by kink, actually, when there is double bond, okay, is when there is a kink. What happens is actually this double bond will prevent the fatty acids prevent the chains from actually packing themselves too close together. So this kink here is important because this will lower the temperature at which lipid melts. So unsaturated fatty acid is easier to metabolize, it's easier to melt because of this kink. because of the double bond. Whereas for saturated, it's not so easy to melt them, and it's not so easy to form chemical bonds and metabolize them because yeah, there is no kink, and yeah, you can't actually form chemical bonds anymore. They're less reactive, whereas for unsaturated, they're able to form chemical bonds. Now in terms of the state, for saturated fatty acid, they are solid at room temperature. And just remember animal fats, okay? Animal fats, they're mainly solid at room temperature. And as we all know, overconsumption of fats, animal fats in particular, is very unhealthy. So just remember, animal fats increases LDL in bloods. LDL is the bad cholesterol actually, and it's solid at room temperature, and there's no kink. You can't just use it. I mean, like, if you were to use fats in food, if you were to leave it outside, it's still fat actually. I mean, like, maybe it might be a bit slimy, a bit greasy, but that's about it. Whereas for oil, vegetable oil, it decreases the LDL levels in blood. So it's known that vegetable oil is healthier than animal fats. So just remember, vegetable oil, it's liquid at room temperature, decreases LDL levels in blood, LDL, the bad cholesterol, and yeah, since it's in liquid state, you can just use it. So yeah, that's how I remember last time. And an example for saturated fatty acid, it's stearic acid, and examples for unsaturated fatty acid would be linoleic acid and oleic acid. So remember, saturated fatty acids found in animal fats, basically the bad fats, no double bonds. Unsaturated fatty acid found in vegetable oils, decreases the LDL levels, and there are double bonds. Alright, so just some functions of triglycerides. So they act as energy source, and there are also energy reserves in the adipose tissue of animals and seeds of plants. So adipose tissue is the fatty tissue, and it insulates the body from cold in the form of subcutaneous fat layer, which is actually a bad conductor of heat. So it warms up the body. It protects the organs from external trauma, and it also waterproofs both animals and plants to prevent excessive evaporation. Alright, so if you've reached this point, thank you very much. Do subscribe and share this video to those who might find this helpful, and I will see you in the next video. Bye!